Hello everyone, welcome to another particular lecture of our reagent chemistry. So this is our class 4. So in our previous lecture we have discussed about the NABH4 base reduction. So this is the continuation of the previous class. So if you are directly come to this particular class, then I will highly suggest to first go in the previous class to understand the how NABH4 actually react, and then come back to this particular class, because here actually we are dealing with Luche reagent. There is the extended version of NABH4 base reduction. Okay, so we are begin with our Luche reagent, but before that we have to understand that why the Luche reagent is important. So for this, basically, let us look on our previous problem that we had discussed in our previous lecture. So if you have a starting material which contains both the aldehyde and ketone group, and in presence of NaBH4, like if you go in the room temperature uh, or 0 degree temperature, then both of the group, that is the aldehyde group as well as the ketone group, both are actually reduced to their corresponding alcohol. But and in the lower temperature, in minus 10 degrees centigrade, you can do selectively aldehyde group reduce, and without harming the ketone group, and ketone group present there. So what if that we want this ketone group selectively reduced in presence of aldehyde group by using NaBH4 reagent? So for that reason, basically we add simply steric chloride in the reaction mixture, and this is actually the birth of the Luche reagent. So if we want to do selectively reduce the ketone group in presence of aldehyde group in the same molecule, and by using NaBH4, then we can use the Luche reagent. And the Luche reagent is nothing but the NaBH4 and steric chloride and water combination of this. And the importance of the Luche reagent is it is selectively reduce the ketone group in presence of an aldehyde group in a same molecule. Just here you can see that the same molecule contains a ketone group and the aldehyde group. Now, if you want to selectively reduce the ketone group, then we can use the Luche reagent to see the ketone group getting reduced to their corresponding alcohol, but the aldehyde group doesn't participate in the reaction. And this is the 1,2 hydride addition. And this is because of the fact that the steric is here, the C is actually chelating with this particular ketone part, makes this particular carbonyl carbon become much electronegative, much electrophilic in nature. And since this particular center become more electrophilic in nature, that means this particular center now attract more nucleophilic attack. Like here in NaBH4, we know that the hydride is nothing but a nucleophile, and this will more attract to this particular center, because now this particular carbonyl carbon center become more electrophilic, and that's why this particular felicited. Now you may be asked that why this type of selectivity is observed, because here also steric will do chelation, but selectively here only chelation favors. So we'll discuss in our subsequent slides this particular part. Okay. So here it is written that Ca3 plus chelates with the ketone oxygen. This is very important. Why we will discuss in our next next slide or subsequent slides. But remember that in Luche reagent, the C is actually chelate with the ketone oxygen more rather than the aldehyde oxygen, and hence it is increased the more electrophilicity in ketone carbon, and hence the particular transformation is observed. So first let us understand the mechanism of this particular thing. So there is a two different mechanism is there. The one mechanism is first that steric chloride is actually mixed with the NaBH4 to form this type of compound. Now this HCeCl2 have both the properties, like it is a Lewis acid due to the presence of this Ce group, and also it have the hydride donor. The hydride donor is nothing but this hydrogen. This will act as a hydride donor now. Now what happened that in this step 2 mechanism, you can find that it is a concerted mechanism where this particular Lewis acid, that is a Ce acidic, is actually chelate with the oxygen of the carbonyl compound or the ketone part. And what happened that it due to this chelation, the electrophilicity of this particular carbon center increases manifold. And so this particular hydride now attack here in a concerted fashion to make this type of compound, and after that the solvent workup there or solvent quenching takes place to break the chelate bond to get this particular our compound. And due to this particular thing, only 1,2 attacks favor in the case of Luche reagent, irrespective of all the alpha beta unsaturation is there or not. All the cases 1,2 attacks favor due to this mechanism. Okay, so there is another mechanism is also there where actually solvent plays an important role to make the nucleophile or hydride donor strong. So what happened that here this is the boron or BH4 minus. So it is a soft nucleophile. Okay, now in presence of uh, alcohol solvent, in presence of sodium chloride, so it will generate this type of RO minus, which actually attach with this particular boron. And now since this particular have due to the donating electron donating ability of this particular OR, so what happened, the negative charge has been much more build up. Like here you can see that all the H has been replaced by OR, and since it is a electron donating group, so what happened that it will donate the electron density. So the electron density in the boron center become much higher, and that's why it has become a hard nucleophile because of the large charge separation. And that's why actually what happened that when it will combine with this particular alpha beta unsaturated carbonyl component combined with the sodium chloride, after chelating this particular center become hard, and now this particular hydride it also become an hard. So what happened that hard interaction is much more facile in nature, so that's why this particular uh, attack favors, and that's why actually we can say that this is purely a 1,2 addition product, not 1,4 addition product, because since the nucleophile become is now much more hard, as well as the due to distillation the electrophilicity of this particular carbon become much increase or increase manifold, and that's why the center become much harder center. So hard interaction become much more favorable, and that's why in all circumstances only 1,2 addition takes place. Now depend upon the stereochemistry. Now since it is a chelation takes place, so in presence of another chelating group adjacent to the carbonyl compound actually influence or alter the stereochemistry, and the stereochemistries determine the cram chelate model. So if you want to learn about the cram chelate model, then you can visit the asymmetric synthesis lectures. uh, if it is uploaded, then you can find in lecture 1 or 2 there is a different stereochemical models we have discussed, and there you can find this particular cram chelate model. Okay, so as I already discussed that the Luche reagent is purely a 1,2 addition reaction. So here you can find that this particular 5-member alpha beta unsaturated carbonyl compound in the case of NaBH4 where the 1,4 addition takes place, but in the case of Luche reagent the 1,2 addition takes place, and this is the major product. Okay, so this also proves that the Luche reagent based reduction is purely 1,2 addition product. Now let us talk about the chemoselectivity that I already discussed in our second slide itself, that why there is a affinity of Ce3 plus to chelate with the ketone itself rather than aldehyde. And due to this affinity actually makes the reaction chemoselective in nature. So basically what happened that the reaction is chemoselective because in the reaction condition, that is our in presence of alcohol solvent, the hydrate formation happens in aldehyde group, and aldehyde group marks due to this. So let us understand this with this particular diagram. So what happened in the case of aldehyde, you can find here that there is only one alkane group is there, alkane or alkyne group is there. So which actually pushes the electron density to somewhat stabilize this particular electron deficiency in this particular center. So but on the other hand, it is an hydrogen, so it is not pushing any inductive effect, shown any inductive effect. So what happened that this particular center becomes a reactive. So what happened that this particular presence in present of this particular alcohol solvent, what happened that this type of hydrate formation takes place because this particular CO is highly polar bond in nature. So what happened, the electrophilicity is much higher here, and this the higher electrophilicity often lead to formation of this type of hydrate. And since it is a formation of hydrate, now there is a no chance of chelating. But in the case of ketone, if you find here, then the both side, the alkane group is there. So this both alkane will have their own inductive effect, which actually stabilize or reduce the electrophilicity of this particular center. And to reduce this particular electrophilicity of the center, this particular ketone are actually preserved throughout the reaction, ketone structure, and this type of hydrate formation is less favorable here. So you can see the arrow like between this particular these two structure. Okay, so in aqueous solution, these two structure, this getting much more favored in the reaction medium, and this carbonyl structure is allow the CaCl3 to chelate, and that's why in presence of both the group aldehyde and ketone, the ketone group has the highest possibility of chelating, and that's why the chemoselectivity is observed. So with this, we have to end this particular lecture. So in this particular lecture, we have learned about the importance of Luche reagent mechanism, and the solvent effect, as well as we have to learn that about the reason of chemoselectivity of the Luche reagent and the 1,2 addition mechanism of the Luche reagent. So in our next class, we are talking about the other NABH4 derivatives in reduction. So thank you for listening.